So just a little bit about us for our newcomers. We are a NIOSH Education and Research Center funded by the Centers for Disease Control and Prevention and stationed here at UT Health School of Public Health. And we have training programs, outreach and continuing education, research programs, and do a lot of events. We have a lot of news on our website and social media, so just be sure to connect with us online through our website and visit our social media channels. So I'm going to stop sharing my screen and introduce our two presenters today. So to kick it off, we're going to have Dr. Robert Phalen. Dr. Phalen is a professor and program chair of occupational safety and health at the University of Houston Clear Lake. And I have with us Dr. Brett Perkison, who is an assistant professor and our occupational medicine residency program director here at the Southwest Center for Occupational Environmental Health at UT Health School of Public Health. So I'm going to go ahead and let's get started with Dr. Phalen. You can go ahead and share your presentation and get started. And then everyone, again, if you have any questions, make sure to enter those into the chat as Dr. Phalen is presenting, and we will answer those during the Q&A session at the end. Thank you.
Great.
Dr. Phalen, you can go ahead.
The slide's showing okay? And okay, so I take it you can hear me too. Well, thank you. Thanks for joining us this morning. I'm going to be talking a little bit about preventative measures for heat stress from an industrial hygiene standpoint. First off, some of these materials were developed under a OSHA Susan Harwood training grant several years ago. So that's kind of the disclaimer. A lot of the materials that are presented here are actually a little bit different than what we did with the grant, but there might be a little bit of content that might be related. But I just wanted to highlight that all the materials that we developed under that grant are available through Susan Harwood. And so if you go Google OSHA Susan Harwood, a lot of those training materials are available for free. And I think we even have a model heat illness prevention plan that for organizations to use as they see fit. That's related a lot to the NIOSH WBGT type protections against heat stress. So the main learning objectives and the main kind of focus I want to take here is on the critical factors that contribute to heat stress. From an industrial hygiene standpoint, our primary objective is to identify hazards and then, control them if needed. When it comes to heat stress, I've reviewed a lot of the heat-related illnesses and fatalities with these investigations that NIOSH and OSHA has done, and just even my own experiences. And time and time again, you can see from the investigations that it's not just one factor that was related to that incident or that fatality. It's a combination of many factors. And that's why it's important to understand these factors. It's not just the heat. It's not just going to be the humidity. It's usually a combination of, doesn't even have to be the humidity in cases. It can just be the temperature, it can be radiant heat loading. And a lot of times it can be the metabolic heat generated by the work that's being done by the worker. And there's other factors like air velocity and the clothing that they're wearing. And so it's really important to understand that, in order to have these heat stress type conditions, often it's multifactorial. And we really need to try to identify those factors and try to control as many as we can. Want to discuss a little bit the importance of physiological monitoring when we have high-risk scenarios. That's very critical. So if workers are wearing chemical protective suits and they're doing physical labor, they're at risk. They're not going to be able to adequately cool down their body. Even if it's 70 degrees out, they can be at risk of heat stress because it's going to mostly block sweating and that evaporative cooling, which is one of our primary methods of cooling our body. And so we'll be discussing some of those kind of best practices in physiological monitoring. And then how can we use these critical factors that, we identify them? How can we use them to implement effective controls and mitigate that heat stress? And so that's the primary objectives here. So first off, with the critical factors, I see it as there's 7 critical factors that can be associated with heat stress. So it's not just temperature and humidity. I think someone's needs to mute. But it's not just temperature and humidity, but it's a combination. If we look at the WBGT type index that is used by ACGIH or NIOSH, and then OSHA has some good resources on that as well. It takes into account 4 of these factors primarily: temperature, air velocity, humidity, and then radiant heat loading, which could be from the sun or from other surfaces. WBGT, if we're applying it, will actually, like from the TLV under ACGIH, will also help us take into account clothing and the metabolic rate and acclimatization. So whether or not workers are acclimated to work in hot environments. So using a WBGT index can really help address these 7 factors. There's also some contributing factors that we need to be aware of, and body weight is one of those, because it affects metabolic rate. And so a lot of the standards that we have, like the WBGT type standards, are largely based on, like the thresholds that they use are largely based on a standard body weight of 154 pounds. And so if you have somebody that has a weight much higher than 154 pounds, their metabolic rate is going to be higher, and that's going to put them at additional risk. And there's really, from my experience, there's scenarios where you may not, like heavy physical activity under certain conditions would be well above any kind of thresholds that would exist. So, it becomes problematic if you have somebody that is maybe like 300 pounds that's working, doing heavy physical labor. There may not be, even if you implemented other controls, it may not be it may be a scenario where they're going to generate more heat than they can get rid of. And then the work-rest schedule can also affect the metabolic rate. And so I'll be discussing a little bit of these in detail, each one. So as far as temperature, that's obviously one of the main factors, but we need to understand a little bit about, heat flow with temperature. So, heat flow is going to flow from a warm body to a cooler body. It can flow to or from our body via conduction, contact with some surfaces or a fluid, convection through air, and then through radiation, which would be like electromagnetic radiation, like infrared, visible, UV, and so, but it typically flows from a warmer body to a cooler body, and so we use this mechanism to help cool our body when our skin temperature increases. It helps if it's hotter than the surrounding air and even surrounding surfaces. We're going to be radiating that heat off of our body, and so it can work to our advantage. But if the environmental conditions are much hotter than our skin temperature, then it can go the other way. We can load heat onto our body, and that could be through radiation. The sun is a good example, So it's much hotter than our skin temperature, and we can absorb that heat from the sun. Even other surfaces like furnaces or even a hot window, if we're near a window, it's getting a lot of sun. Just that heat radiated could add heat to our body, or through convection, through air. If the air is much hotter than our skin temperature, it can add heat to our body. Air velocity, another important concept, and it can affect convection and that heat transfer to or from the body. And it can also affect evaporative cooling, which is another way that our body can get rid of heat. So I've made two distinctions here. On the left, if air temperatures are near or less than skin temperature, then if we increase the air velocity, we can effectively increase sweat evaporation, as long as humidity is not too high. And we can remove heat also through that convection. So our skin temperature is going to be able to, that air is going to be able to take heat away. However, if the air velocity is decreased, then that's going to decrease evaporative cooling, our ability to cool our bodies. It's also going to decrease that heat loss, so that getting rid of heat. So when air temperatures are less than skin temperature, or at least near it, and we don't have excessive humidity, increasing the air velocity can really help cool the body down. However, on the right there, if the air temperature is much higher than skin temperature, we have to be aware of the fact that we may have some convection heating of the body, some increased heat transfer due to convection. And that's going to be especially true if the humidities are higher. And so essentially, if you think about those ads where they have convection ovens that can cook your food twice as fast, it's the same principle. They just have an oven and they add a fan in there to increase that heat transfer to the food. And it's the same principle. So now sometimes evaporative cooling can offset that. And so the air movement may be better than not. But, when humidity is a little bit higher and the air temperatures are much higher than skin temperature, we may be looking to decrease that air velocity to slow down that heat transfer. Another way we can do that we'll talk about is through clothing. So you don't want to add multiple layers, but you can add clothing coverage of the skin, and that just slows down the air in that heat, that convective heat transfer. For humidity, that largely affects evaporative cooling. And so relative humidity is typically what we measure humidity as, and it ranges from 0 to 100%. It's a measure of how much water the air can hold, basically. So at 100% humidity, it's saturated. It can't hold any more water. And so when we get conditions where the relative humidity is, say 90% or above, evaporation of sweat from our body is going to be much less, because it doesn't really have much where to go. And so we have to keep that in mind. And another fact is, if we have humid, hot conditions, adding something like a fan that is evaporative cooler type fan may not help much, because the moisture there doesn't have anywhere really to go if that air is saturated. But when it's drier, we can have efficient evaporative cooling. As far as radiant heat, it flows, like I said, from warm to cool surfaces, and it can come from various forms of electromagnetic energy, and that includes infrared, visible, ultraviolet, and it has the ability to pass through the air without significantly heating the air. But whatever surface it comes in contact with, it's either going, it's either going to transfer that heat, that energy to the body, or on the other side, we're going to be able to radiate if our skin temperature is warmer than the surrounding surfaces, basically. And so the examples is not just the sun, but the sun can add quite a bit of radiant heat to our bodies, but also anything with open flames or embers or molten metal or glass that are glowing, surfaces of furnaces, even metal surfaces that are being heated by the sun can radiate quite a bit of heat. Windows can radiate quite a bit of heat, and we have to understand that principle that it's not really interacting with the air; it's interacting with whatever surface that radiant heat is coming in contact with, and typically it's flowing out from all directions from that surface. As far as clothing, this can be our friend or our foe. So, and I'm making two clear distinctions here that were similar to that I was doing before with the temperatures of the air relative to our skin. So on the left, if the temperatures are near or less than skin temperature, then less clothing coverage and more breathable fabrics can improve that heat dissipation. So we want to help encourage evaporation. Obviously, if someone's out in the sun, you don't necessarily want to have them their skin exposed. From sunburns are going to also put them at risk later of heat stress if it damages the skin. But more breathable fabrics, and we can encourage that evaporation to occur. On the other side, if someone's wearing thicker clothing, double layers, it's going to reduce that heat dissipation. And then if they're wearing an impermeable type chemical suit or something like that, it's going to prevent that evaporative cooling. So, so to keep that in mind. When the temperatures are much higher than skin temperature, we worry about that convective heat transfer. Then, when that air is moving and we have those conditions for convective heat transfer to our skin, increasing the coverage can help reduce that transfer. So we wouldn't increase the number of layers. We would just make sure that the skin had some light, breathable surface there to slow down the air. And prevent that convective transfer. It's the body is kind of adapted to maintain its temperatures under hot conditions. It's not perfect. Under cold conditions, the body does have a response to reduce convective heat transfer. It's actually heat loss from the skin. We get goosebumps, and the goosebumps will actually help reduce that convective transfer. It slows down that air velocities kind of at the skin, but we don't have that with heat and hot conditions. And then we can also use lighter and reflective clothing to reduce that radiant heat transfer. Under extreme conditions, like in the case of the picture where they're wearing chemical type protective suits, there's going to be an increased risk of heat stress and heat-related illnesses because it's going to impede the ability of the body to evaporate sweat, and that's primary mechanism of cooling. It may even affect, our body's ability to radiate heat off of it. And so we need to take additional precautions, additional measures to try to protect those workers. So one of those that, this was from an industrial hygiene standpoint, I would always be diligently monitoring signs and symptoms of heat stress under these conditions, especially early signs like cramping. And that's probably the most common thing I've seen is workers in these types of conditions. They're doing some physical labor like sandblasting or hazmat work that they'll start to get cramping because they're sweating profusely. They're not cooling down. They're usually not taking in enough fluids under these types of work conditions. And so that's been the most common thing I've seen. And, I'm going to pull them off the job and we find something else for them. And not being acclimated is probably one of the more common things I've seen too under these types of work conditions. But we can also do physiological monitoring of the body temperature and then also heart rate recovery, which is a pretty good one to look at, a little bit easier to evaluate and measure, pretty easy to implement. And then for dehydration issues, body weight and urine color can help. And those are typically done, the workers can monitor their own body weight and urine color. And that's really important because a lot of heat stress can be related to dehydration. So it's important to ensure that they're properly hydrated. As far as metabolic rate, the major byproduct of when we're doing physical exertion is heat. And when we overexert ourselves, the body's going to produce more heat than can be dissipated. And that can lead to heat stress. So ACGIH and NIOSH have guidelines to determine that metabolic rate that can help in determining whether or not the body is producing more heat than can be dissipated. That's the key thing when we're looking at using a WBGT type evaluation and a threshold limit with that. You know, that's the whole goal, is to determine if the body's going to be gaining more heat than it can get rid of. So for acclimatization, you know, this is really important that to understand that the body can adapt to hot conditions, and so, but it takes some time, and but when the body adapts to hot conditions, it's going to become more efficient. So it's going to be become more efficient at sweating and cooling the body. We'll have less salt loss, less electrolyte loss. You know, we're going to be able to maintain our core body temperature more efficiently. It's going to reduce the strain on the heart because the mechanisms that send blood to the skin, that blood flow to the skin, is going to become more efficient. And we even see improvements in heart rate recovery after bouts of physical activity. And so it's really critical to have an understanding that for one, workers that are not acclimated to hot conditions are going to be more susceptible to heat stress and heat-related illnesses in that critical period, you know, which is usually the first couple weeks. And those that are acclimated are going to be able to handle the heat a little better. So the human body needs typically about 10 to 14 days to become acclimated to a hot environment. And there are guidelines. I think the best one to go to is the NIOSH criteria document on heat stress. And I think it's in the resources at the end of this. And they have guidelines on how to basically gradually increase the exposure to the hot environment over that period to allow workers to acclimate to those hot conditions. Most of it involves avoiding prolonged exertion during the hottest times of the day and scheduling the heavy exertion for the cooler parts of the day. And you just gradually increase that physical exertion during those hotter periods of the day. It's also important to understand if someone took an extended break, like let's say a week off for vacation, and they came back, let's say they were acclimated, but they took a week-long vacation, and they were not exposed to heat in heavy physical activities, it's going to take 2 or 3 days for them to reacclimate to those hot conditions. Like I said before, there's some other additional contributing factors associated with metabolic rate. We have body weight, that heavy people have a higher metabolic rate. The standards are based on a 154-pound person, which you know, we really have to be aware of, that if we have somebody that is much heavier than 154 pounds, even with adjustment, it may be very difficult to accommodate and implement controls that are going to be fully protective. And so there are adjustments for body weight under the ACGIH TLV when we're doing metabolic rate calculations, and even the Osha technical manual has some guidelines on that. It's another very good resource when it comes to heat stress. The work rest schedule, you know, this is another one that's going to affect metabolic rate and the body's ability to cool itself. Rest really does allow the body time to eliminate excess heat. A lot of this is kind of due to the fact that the muscles are taking a lot of the blood flow, and they're generating heat also. But if you're doing heavy physical labor, the muscles are going to be requiring that blood flow. It's going to impede the ability to get blood flow to the skin to be cooled, and those muscles can be generating heat, and so that's important. The one thing from an industrial hygiene standpoint, you know, work rest schedules according to the WBGT guidelines, like the TLVs and the like, are always very difficult to implement. I've always taken an approach to evaluate all those 7 critical factors that I can, and even implement physiological monitoring so that we can still maintain productivity. It just doesn't go over very well if you say, well, we're not going to make any changes, we're not going to make any improvements. The workers are just going to work for 15 minutes and they're going to not work for 45 minutes every hour. It's just not feasible from a productivity standpoint. So, but in some cases it may be necessary under extreme conditions. And there's guides on the work rest schedules under ACGIH and NIOSH. It's important to make sure that workers understand the importance of frequent rest breaks and shade. The rest breaks, obviously, even if it's a mini break, it's going to allow blood flow to the skin, to return to the skin if there's physical activity there, and aid in cooling. Obviously, if they're stopping that physical activity, the muscles are not going to be generating that additional heat in the body. And then it's going to allow that heart rate to recover. I like to think of this as more like, it's like credit debt. We build heat up in our body, kind of almost like credit card debt. It builds up and it builds up, and there's a certain point where you just can't pay it off. And so little frequent rest breaks are like payments, that we need to make those payments to prevent it from getting to a point where there's no recovering from it. And then shade really does help during these breaks, especially if there's a radiant loading. I mean, we really should be providing shade even under the work conditions. And I'm seeing more of that, which especially with construction, which is great. Equipment that has shades, even shaded areas where they can go and do their planning and their work. And then in some cases, even shade while they're working, outdoors. It's also important to make sure that workers understand the importance of consuming water throughout the work shift. Heat stress can be related to dehydration. We don't want to have them consume too much water, but generally 1 small cup, 8 ounces every 15 to 20 minutes allows them to get that needed break that they need from the physical activity and rehydrate. We have to be aware that too much water can be dangerous. So, water intoxication is a thing. We're seeing a lot more cases of water intoxication, and so it can affect the electrolyte balance, basically sodium balance in the blood, and even lead to other effects like headache, nausea, vomiting, but that's been an issue we're seeing more and more. With those that think that they need to consume large amounts of water. You see them sometimes carrying around, gallon or 2 gallon jugs of water. And so it's important to understand that. And there are fatalities that have been associated with excessive water intake. It can disrupt that electrolyte balance and lead to kidney failure. So I wanted to talk a little bit about physiological monitoring. So when that risk level is high, there may be a need to incorporate physiological monitoring. Most likely there would be. And you see a picture here. This is, with the military, that they're taking an oral temperature monitoring, probably when they're doing their boot camp, or if they're out in the field under hot conditions, just to detect those early signs of heat stress. And that's really the goal with physiological monitoring, is to be able to detect those early signs of heat stress before it gets to a thing where we have to see symptoms. We want to be able to prevent it to getting to a point where they're actually have heat exhaustion or heat stroke. And so if you look at the NIOSH criteria document, the two probably better options in all the studies that they've looked at and evaluations they've done are oral temperature and heart rate recovery. And I would agree, these are easy to implement. There's a lot of devices out there for doing oral temperature. They're very reliable. there's some plus and minuses with them. I really do like heart rate recovery. A little bit easier to implement. It's very well correlated to oral temperature. I've never had much luck with, I know these might be questions, but with the ones where you do the forehead or the ear, like in the ear, those types, they're just not as reliable. So when we've had to use the devices where you stick the probe in the ear to get it, usually you have to take about 5-6 measurements, and you still are not completely sure how reliable and how valid that data really is. So, and then additional measures we can use are body weight and urine color, and that's more that the workers can monitor. So as far as oral body temperature, the general guidelines is that that if you're going to take oral temperature, obviously they shouldn't have had any cool or hot liquids or food within 5 minutes of the reading. So generally what you do is they're doing physical exertion, they're coming off to take a break to get some water, just take it just before they drink their water or they take a food break. And general, just a very general guideline is that the oral temperature should not exceed 99.5 degrees Fahrenheit. But when it's elevated above 99.1, we want to look at some protective measures, implementing some, which may mean adjusting that work-rest schedule or the frequency and duration of the rest breaks, So this is something that as an example, something that provide like workers and safety people out on the job sites, like usually on a general, like a little card, so they know how to interpret those oral temperature readings. And so you see basically when you get to about the 99.1, just above that, we want to take some precautions, increase the shade, the water, the rest cycles and durations, and maybe even decrease the physical exertion, especially if it's at the hottest time of the day. When we get 99.6 and above, 99.6 and just above, we're going to have to suspend work for that worker. We need to get their body cool. And this is the primary concern is more like the heat exhaustion. So move them to a cool location, have them drink some cool water, electrolyte replacement, and monitor the body temperature to ensure that it doesn't get to the point like to heat stroke. When we're at 101.2 and above, this is an extreme condition. This is where we need to call 911, but at the same time, we need to take really extreme measures to cool their body down, before 911 arrives. And that's removing excess clothing, spraying their body with water, fanning vigorously, packing ice in the armpits, groin regions. And if you don't have ice and stuff, submerging them in water, doing just if you have had a child that's had a high fever, you can imagine what you would do. Most of us would put them in a cool shower or a bathtub, same thing. And so water can take heat away from the body and be very effective at that. So it would be the same type of activities. But when you get into this realm where the body has a very high core temperature, there can be a point of no return. For heart rate recovery, the real basic just guideline, and once again we put these like on a little card so they know how to check it. But I find this the simplest ways. They go to take a rest break. They just check their heart rate, and the little finger devices, the pulse oximeter type meters, can be very effective at checking the heart rate. And so the heart rate should drop below 110 within a few minutes of rest from physical activity. If it doesn't, then you check it at a couple 2-minute intervals to see if it's dropping efficiently. And if it's dropping more than 10 beats per minute every 2 minutes, then that's a good sign that the body is able to recover. That it's like that credit card debt. Those payments have worked. But if it's not, that means the body is still working. The heart is still pumping to try to help cool the body down. And like I said, heart rate recovery is very well correlated to core body temperature. So it is an effective measure to determine if someone is heat stressed. And the whole goal is to try to catch it before they get to the point where we're having to try to cool their body down and have them go to the hospital. For monitoring body weight, this an accurate scale they can read within plus or minus a quarter pound. Those are usually around $25-30. You can even, they're pretty durable. The idea there is that we're measuring body weight, and that we want to make sure that they're staying properly hydrated, especially if they're sweating a lot. Are they taking in enough fluids? And the general rule is it shouldn't drop by more than 1.5% of their body weight. That means if someone's 150 pounds, they shouldn't drop more than 2 pounds of body weight from sweat. If they're 200 pounds, then not more than about 3 pounds. I know when going to the gym, I notice people will go and they'll do a heavy duty workout and then they'll step on the scale. They tend to seem pretty happy with it, but they're not losing fat, most likely they're losing sweat. So they probably should be more concerned about hydration in those cases. For urine color, this is another one that can go on a little information card. I know others have done this in the field. This comes from the NIOSH criteria document. Obviously, normal urine should be pale yellow. And the darker it gets, the more indication of dehydration we see. And so we always have to be aware that, some diets and medications and illnesses may affect these results. I know vitamin B is one that can kind of darken the urine. And so workers would need to be aware of that and they monitor it, ensure that, it's not getting any more darker. So that's kind of general principle there. As far as prevention, how do we implement some of these ideas on critical factors as controls? And what I'm going to show you is just, time-wise, I don't have much time here, but I want to just go through and cover some. And then the ones that you'll see in blue, and I'll kind of try to highlight those too, are the ones that are going to be more effective typically as a control measure. So we also have to keep aware unacclimated workers are going to be at a greater risk. And so we do definitely want to take additional precautions if we have unacclimated workers. Working to acclimate workers can definitely be a protective measure, preventative measure. So when it comes to implementing heat illness prevention strategies, a good approach is to first start off with implementing controls to reduce that risk level based on what we know is going to be a high risk. And it's basically going after those areas of the environmental conditions or all those factors that we discussed earlier, which one is contributing most to the heat stress conditions. And then obviously be aware of the possible need of physiological monitoring if we have high risk levels. And then we turn to engineering controls, administrative controls and PPE type controls, our standard hierarchy of controls, But really the first one there is kind of like, can we eliminate some of these risk factors? So in that first part, implement controls to reduce the risk level, this is where we would be using that WBGT and the related TLV or recommended exposure level that would be associated with use of a WBGT. So WBGT stands for wet bulb lobe temperature. It's a heat index that takes into account temperature, radiant heat, air velocity, humidity. But when we apply it, like using the NIOSH guidelines or the ACGIH guidelines, we're also going to be taking into account clothing, metabolic rate, and even the work rest schedule. So, and so when we do the WBGT, we can get an effective value that's going to take into account the additional factor of clothing in addition to those environmental conditions. And we just want to try to lower that as much as possible. And so the approach is if radiant heat is a primary factor it's really adding, the globe temperature is adding a lot to that WBGT measure, then, we can work to reduce the radiant heat. If air velocity is a contributing factor because the temperatures are high and maybe the humidity is high, then that's something that we may need to look at. If clothing is an issue, we can look at if it's feasible. And on the other end, we want to increase the threshold because the thresholds are based on the metabolic rate and the work rest schedule. So we can adjust that. We can provide tools to make the job easier to reduce that physical exertion, and that can help reduce that metabolic rate. We can also maybe adjust that work rest schedule. So, if we increase the threshold and decrease the environmental and other conditions associated with the WBGT, that can effectively push it to where the body is not generating more heat than it can get rid of, because that's what the WBGT helps us evaluate. From a temperature standpoint, you see these are all in blue. So I found the most effective one is just rescheduling work for cooler times of the day. I've had scenarios where the workers are out there, it's 120 degrees out, ground temperature is even hotter. They're out there working during the day, but it gets cool at night, and it doesn't get hot until the sun comes up at 10, and then it cools down right after 5. So, easiest thing to do is just schedule that work time when it's cooler out, and that seems to be the most effective from my experience. Rescheduling heavy physical exertion and rearranging your activities, plan better so that you're not doing heavy strenuous work between 2 and 4. Those are generally the hottest parts of the day. Almost every NIOSH fatality investigation I reviewed, the fatalities are right around this time, around 2 to 4 p.m. It's the hottest time of the day. And so it's something we need to be aware of. Moving work activities indoors, pre-assembling products indoors under controlled conditions, things like that, working smarter can help. For air velocity, just have to keep in mind the air temperature and humidity are going to be important. So when the air temperatures and humidity are not excessive, then we can increase the air velocity using fans, and that will help with evaporative cooling and even potentially some convective heat loss from the body, which would be nice. And then when the air temperatures are significantly above skin temperature and the humidity is higher, we need a shield against that air velocity or decrease it to reduce that convective heat gain. For humidity, this is one of the more difficult ones to control. If it's indoor settings, you might have ability to control the humidity through local exhaust ventilation. Humidity does change throughout the day. The unfortunate thing is a lot of times humidity is higher, sometimes early mornings. And so that means the temperature may be lower, but the humidity may be higher. So it's a little bit of a give and take on temperature and humidity. But indoors, there's things that we can do to reduce that humidity. Local exhaust ventilation is going to be probably the better one, but some can use dehumidifiers to try to help control that. For radiant heat, the most effective controls are going to be providing shade from the sun and then radiant barriers. And I just want to quickly say one thing about the radiant barriers. We've tested some of these out. I've had some grad students test it out, and you can, like, for $100, you can get a huge roll of radiant barrier, and it's line of sight. So if you have a radiant source, you just have to put it between the source and the worker, and that can be fairly efficient. So, but a lot of the radiant barriers that are used for like roofs can be pretty inexpensive, and it can be hung up and provide good protection against radiant heat transfer. Clothing, reducing the clothing layers when feasible, when it can be done safely, is important. Adjusting that clothing coverage, like I said, based on the temperatures relative to skin temperature, and those considerations, and then looking for lighter colored, more breathable clothing during especially the summer months is pretty common. I have a picture of a vortex. I mean, I found good success using these vortex devices if they're on supplied air, or if they're working in an oven in types of conditions. We would give them a hood with supplied air, and it kind of goes that you want the air coming in around the head and then flowing down through the body. And then these little vortex cooling devices really do, it's like a little air conditioner for the air, and be fairly effective. For metabolic rate, basic thing we want to do is look to find aids and tools to reduce and lessen the physical exertion. And the example I have there is an auger. Instead of having them dig holes by hand, we can use something like a powered auger. And we can also adjust the work rest schedule to reduce that metabolic rate. But that's feasibility wise, it's better to go with power tools and aids to reduce physical exertion. So I think I finished just in time. Did not leave probably much time for questions. But here's some resources, and I definitely recommend you go to the OSHA technical manual chapter on heat stress. That's a very great resource. And then also the NIOSH criteria document for a recommended standard on occupational exposure to heat in hot environments. That's my last slide.
Thank you, Dr. Phalen. And we'll take those questions after Dr. Perkison's presentation during the Q&A session. So if anyone does have questions, go ahead and enter those into the chat, and we'll moderate and host those at the end of both presentations. So again, thank you, Dr. Phalen. That was a great and very informative presentation. So we'll go ahead and transition now to Dr. Perkison. Dr. Perkison, if you want to turn on your camera and share your screen, and if everyone else can turn off their videos since we're recording, you can feel free to turn those back on during the Q&A session. All right, Dr. Perkison, go.
Yeah, great. Thanks, Michelle. And really glad to be part of this presentation today. And Dr. Phalen and I have tried to complement each other a little bit on our presentations. I'm going to be focused more on health effects related to heat stress. I do have a confession up front, is that I usually weigh myself after I work out. I think that's good for the psychology for decreasing your weight. So something good to know. That I'm glad he confirmed that occurred. What we're going to do today, I have nothing to disclose, but what we're going to talk about is, I'm going to start off with a high-level view of looking at why is heat stress, why are we concerned about that more than ever, and looking at the effects of climate change and why heat stress illnesses are increasing. Then we're going to talk about the physiology and some symptoms of the different gradations of heat stress. And finally, I'm going to try to complement what Dr. Phalen's already mentioned to you about heat stress prevention and management strategies. And as far as my background goes, I'm board certified in family medicine, occupational environmental medicine, and prior to coming onto the School of Public Health, I have managed heat stress programs in the industry. So this is a subject near and dear to my heart. So talking about sort of a high-level view is why are we more concerned, and why are heat stress illnesses occurring at higher rates than before? Looking at really the description of the greenhouse effect is really a good explanation for this. Ultraviolet light comes from the sun and enters the atmosphere at about 290 to 400 nanometers. It hits the Earth's surface, and it is absorbed by plants and soil. That heat energy is absorbed by that. And then what is emitted from the plants and soil is infrared energy at about 2,000 to 15,000 nanometers, much longer wavelengths. Those wavelengths, lower wavelengths, is what carbon dioxide absorbs. And so with increasing concentrations of carbon dioxide, you have an increased absorption of heat energy. And carbon dioxide at a given concentration stays in the atmosphere anywhere from 300 to 1,000 years. So it dissipates very slowly. And you've probably seen in the news the effects of the poles of the Arctic and the Antarctic, and that the white snow reflects energy in UV light, and that same higher frequency goes to the atmosphere without being absorbed by the carbon dioxide. So that's why it's all sort of tied together with what's changing at the poles. There are a lot of other factors that affect temperatures. And if you look at the graph there on the top, you can see for any individual 10-year period, there's a lot of fluctuations. It goes there's ups and downs. That's related to solar activity. It's related to volcanic activity. It's related to changes in the Earth's orbit. But you can see there's this slow increase since we've been measuring temperatures although it continues to go up and down, the average temperature continues to climb. And if we're able to go back even further in time, if we look at ice cores back to the last 800,000 years, and you can see again, CO2 levels go up and down through different atmospheric effects. But if you look to the very far right, you see these concentrations that we're at right now of around 400 parts per million are really unprecedented in any of these previous episodes. We're really entering a new atmospheric effects that's unprecedented, and we need to keep that in mind when we're trying to treat our workers and protect them. And then the other aspect of this is just that if you look at this graph, heat-related illnesses in the upper left-hand corner is just one of a myriad of different emerging health threats to our workers with these changes in climate change. And so just keeping in mind that respiratory diseases, allergies, asthma, cardiovascular disease all change, which we don't have time to go into today. But as you look at it, it really requires a holistic approach for protecting our workers. And finally, from this study that looked at heat wave characteristics of 50 large U.S. cities from the years 1961 to 2018, we can see that the average number of heat waves per year has been climbing steadily. And so you can see in the map there in the Gulf Coast states, you're having upwards of greater than 8 heat waves per year that are greater than what was previous prior to 1960. So our frequencies are increasing. Our strategies need to be more aggressive. The other thing that I'll mention on that top graph is that you can see in the more northern parts of the United States, greater than 2 to 4 heat waves, much lower. But these are in areas that are not really conditioned for heat waves at all. There's less air conditioning, there's less heat wave stress prevention programs, less misting tents, all the things that we really need that Dr. Phalen discussed to prevent heat stress. And so we need to be aware of these changes, that the different parts of the country need to have more aggressive heat stress protocols. And then also the heat wave season is increasing as well. And so again, in the Gulf Coast states, you can see greater than 80 days increase in heat wave seasons from prior to 1960. And so that's greater, that's over 3 months longer. So really these heat stress programs need to be enacted very early in the year and continue late in the fall. And budgets and other projections for heat stress programs need to be accommodated for that. I'm going to talk now a little bit more on the physiology and also talk a little bit about nomenclature of heat stress. So when we refer to the term heat stress, it really talks about those external factors that are affecting the body, the amount of work that's being done, and then the environmental exposures, the amount of UV light that somebody's getting, the amount of radiant heat, some of those other factors that Dr. Phalen mentioned. All those are really the term heat stress. The effect on the body is heat strain, and how our body adapts to heat strain is predicated on factors like acclimatization and other factors. And then the actual manifestation, when the body's no longer able to compensate, is what we term heat-related illnesses. If we break down heat-related illnesses further, there's a range of symptoms. And I'll try to complement again what Dr. Phalen mentioned, but we have heat rash sort of on the lower end of the scale, progressing to heat cramps, heat exhaustion, and then finally heat stroke. So heat rash is more commonly seen in kids, but it does occur in adults, and it can be a sign in some of your workers that people are beginning to have heat-related illness. And heat rash is also called prickly heat, and so it can manifest itself as an uncomfortable feeling, a prickly or tingly feeling, and you have these blisters, and the blisters or pustules are very small, and they can be either clear or they can be red, and they're more likely to occur in the areas of the skin that there's a higher temperature at. So you think about it under the arms, the groin, the breast, axilla. Those areas are more manifested more often. Moving up to heat cramps, as you expect, it's muscle cramps, but it's more commonly in the legs or the abdomen. And this often occurs when a person has had heavy perspiration, but they haven't necessarily replaced their electrolytes. So electrolyte replacement over a long period of time, water is always good, but some electrolyte replacement is also needed. Particularly potassium gets depleted, can result in these muscle cramps. Progressing to heat exhaustion, what you'll see is heavy, profuse sweating that just does not slow down even when the person's at rest. This can often be kind of subtle. Sometimes the most initial symptom can be slight confusion or disorientation. Some heat stress programs will have questions where you simply ask them where the person is and what the time is. Sort of the usual questions of orientation can sometimes be the first thing to kind of give this away that heat exhaustion is occurring. They can complain of being fatigued, slightly pale, and then as the symptoms progress, nausea, vomiting, headache, dizziness, fainting. The skin sometimes can be cool and clammy because you're profusely sweating. The sweat glands are still working, and you're able to compensate at this stage. And so sometimes body temperature can still be normal. And I agree with Dr. Phalen on the resting heart rate can be sometimes really a good sign to kind of indicate when a person's able to compensate and when they're not. And then finally, heat stroke. And this is where the body is not able to control its core body temperature, and you actually see an increase in temperature. The sweat glands are also not working. They begin to stop working. They can't function anymore, and so a person actually has dry skin. Once these mechanisms fail, you can see a rapid rise in temperature. Within 15 minutes, the temperature can go from 98 to 105 on an oral temperature. And if this reaches this stage, immediate treatment is needed, or it can result in death. One of the things I want to stress is that as in being in occupational health is really our goal is to prevent this altogether. But also in those cases of heat exhaustion, in trying to determine should a person be taken to the hospital, should they be evaluated by a physician, is to really look at those symptoms of heat exhaustion and be comfortable with them. And you want to err on the side of conservancy in that you want to send them to the emergency room if these heat exhaustion symptoms are beginning develop, because there's a certain point where really a person needs IV fluids and they need to be monitored in an emergency room in order to prevent this from becoming on to become a fatal heat stroke case. And so just to kind of review, well, what would the emergency room be doing for somebody that's developed late heat exhaustion, early heat stroke? Really, rectal temperatures are needed to check the core body temperature, to really monitor it. And then we need to do some lab work. We need to monitor sodium, potassium levels, as well as kidney function. Creatinine, myoglobin are two common lab measures to look at, because as muscle begins to break down from heat stress, and that's one of the symptoms of heat stress, is you become dehydrated and no longer able to control your temperature, is your muscle breaks down and the kidney stops being able to filtrate these breakdown products rapidly, and so kidney failure can result. So that needs to be monitored closely over a period of time. We talked about checking the color of your urine. Specific gravity is a more accurate test that can be monitored in the hospital. And then I mentioned the muscle function already, which is the medical term for muscle function breakdown is rhabdomyolysis. In addition, because of poor perfusion, other organs can begin to break down, and so imaging tests are needed to monitor that. A little bit about, I know Dr. Phalen had mentioned different treatments, and I think it's also worthwhile looking, and this is based on a recent study that looked at the rate of core body cooling with different methodologies for treatment. And immersion in ice bath, you can have a cooling rate of around 0.16 to 0.26 Celsius per minute. So you think about that 105-degree core body temperature, you're trying to get it down to 98 degrees. And so it's going to take time, and that's where these minutes can really make the difference between life and death. Immersion in cold water is similar to the ice bath. It's a similar range that was found, so somewhat equal on that. But it also found that when IV fluids are given, is that you have less damage in the long run to end organs. You're getting cold saline directly in to the circulation system to cool down these end organs, and so it results in less death and disability. Continuous monitoring, and then just to reemphasize is that when we're in early heat exhaustion, fans, wet clothes, compresses, beginning the AC rest, those are useful, but not when your core body temperature reaches 105. You can see that those rates really cool down 0.03 to 0.06 degrees per minute. And at that slower rate of cooling, you're going to have in-organ damage that will be irreversible by the time those methods work. And then just looking at, when you're looking at medical surveillance for heat stress, if you spend a few minutes and just looking at this slide, you can see all the different factors that go into the development of heat-related illness. And so acclimatization has been mentioned, but there's a number of other factors that go into this. The older we get, like so many other things, we develop less resilience to the effects of heat. If you've had a previous heat-related illness, you are less able to recover. So a lot of those sweat glands are irreversible, and so a person that has had heat stroke in the past is usually not going to be able to deal with the heat as effectively as before. In addition to the environmental sources, thinking about what are indoor radiant heat sources, if they're near active internal combustion or other mechanisms that generate heat, all these things kind of come into play, and that's why the wet bulb globe temperature is so useful to monitor, because it takes into account both external and radiant heat. The amount of physical exertion that's one doing, as one might expect. So somebody may be doing just fine in a particular type of job, but if they're being asked to do something that involves more exertion, then they're no longer, they might begin to develop heat stress. Pregnancy, very important, as we have more women in the workplace, that as you might expect, when you're pregnant, your physiology changes. You're no longer able to compensate for the effects of heat during gestation. Medication. So many of us now have high blood pressure, and one of the first lines of treatment for high blood pressure are diuretics. Diuretics are great for controlling blood pressure, but they also can affect your sodium and potassium balance, making you more susceptible to the effects of heat-related illness. And they can also, diuretics, as you might expect, you're losing some of that intravascular volume to control your blood pressure, and it makes you more at risk for heat-related illnesses. So that's a constantly moving target. So as your employees go to physicians, get put on medications, I would recommend some system in place where that is reported to your health department, and some compensation is taken in place to evaluate the employee to make sure that they're dealing with this new medication okay and dealing with the effects of heat. And then physical conditioning and other underlying health problems. So all these really come into play in a medical surveillance program, and to be able to kind of evaluate these and do it fast and have a good environment where the employee feels comfortable with reporting some of these issues to your employee health. The other aspect of heat-related illness is that it presents differently when people are at work than what we would say non-work related or classical heat stroke. So the first three characteristics there are obvious. Your working age population are the ones that are affected. They're out there doing this manual work, whereas just sort of general heat stroke, the young and the elderly are more susceptible. The activity is usually associated with strenuous exercise. Many times, again, it's a particular job, a particular thing that's very strenuous that all of a sudden a person develops heat stress. Sweating profusely can often be prolonged, that heat exhaustion on into heat stroke. So sometimes that can fool one into thinking maybe a person's compensating better than they can because perspiration persists in exertional heat stroke. Also, as I mentioned earlier, it doesn't necessarily have to be 105 degrees outside when heat-related illnesses occur due to this factor of exertion being a component of this. So someone that's not acclimatized, that's doing exertional work, can very well develop heat stress related illness when the temperature's in the 90s. So again, sort of being aware and putting in your heat stress prevention measures early when there's high volume exertional labor that's going to be planned for. And then lastly, this feature of heat stress, this rhabdomyolysis or breakdown of muscle products, occurs more often in work-related heat stress. Again, somewhat intuitive. If a person's using their muscles, and that organ is affected more often. And so people in this category are more susceptible as a result to kidney failure than classical heat stroke. You've probably heard, it's been in the news, and Dr. Delclos, who's in the audience, has done a lot of work on sugarcane workers and other workers in Central America. We're not sure if it's only due to heat that factor is occurring, but it certainly is a factor in that young men in that part of the world are developing kidney failure much more commonly than they formerly did. So being aware of that, and again, having a lower threshold for having a person go in and to get monitored to prevent this sometimes devastating illness is important. And then lastly, I'll circle back to kind of the high level view of as you're planning. I think it's important to realize this is a dynamic situation in that these heat stress illnesses, the number of heat-related heat days that heat stress prevention measures need to be enacted are occurring or becoming longer. Right now, we're about estimated about 1.6 degrees on average at a global temperature above pre-industrial times. And you can see some of the dramatic effects already related to high heat index days in the United States. These projections can show that depending on how well we're able to control carbon dioxide emissions in the next 30, 40 years will depend on where we kind of level out at. And so you'll see a term that's commonly referred to as the RCP, or Representative Concentration Pathway. And really what that is that it's a projection based on how well we're able to control carbon emissions, but it does give us a guideline for where temperatures will settle out in the atmosphere. And you can see probably the best case scenario is that emissions peak in 2040 at about 2.3 degrees above pre-industrial temperatures. And so you can think about the heat stress days that we've got now at 1.6 and what's that going to look like at 2.3. And then if we're not able to curb those, you can see more dramatic effects, 3.8, on sky's the limit if you still don't control the carbon emissions. So just really important to follow these issues, be part of the conversation with your operations people on how to prepare for each coming year, but also looking at 10, 20 years down the road and be part of this discussion. That this is critically important for all of us to understand, be aware of the science, focusing on the science of this so that we can be prepared to protect our workers. And that is all of my presentation, and look forward to taking questions at the end of the presentations.
Thank you, Dr. Perkison. Okay, well, we do have a few questions. I'm going to start off for a few that I think are for Dr. Phalen that came in right after his presentation. So Dr. Phalen, there's a question on if energy drinks contribute to having an episode of insulation.
Is that a question for me, or?
I think so. It came in right after your presentation. So I guess if either one of you could answer that, but yeah, I think that was addressed to you, Dr. Phalen.
Okay. I don't know. Did you want to take that?
Sure. What, could you repeat the question for me one more time, Michelle?
Sure. It's regarding energy drinks and if those contribute to having an episode of insulation, which I think is what related to like heat stress, heat stroke, other factors.
Yeah, no, energy drinks are good in that they're electrolyte replacements. So I would recommend them, not exclusively. I think, you can still, we talked a little bit about having too much water. But really you have to go through a lot of water. Water is still kind of the key replacement fluid. One of the things if you look at Gatorade, for instance, probably most of you know that Gatorade was developed for the University of Florida Gators football team, and it's electrolyte replacement. And it's a good solution. It's a little high in sugar. Some of the ones, what we recommend, G2 now has a lower sugar content, that it's a little more physiological. A lot of times we recommend diluting a drink like Gatorade with 1-to-1 with water, and drinking that over a period of time. Trying to have that available frequently rather than trying to drink it all at once. Regarding side effects to drinking too much of it. Again, you have to drink a lot of it to have a problem with it. And I guess the other thing regarding drinks, I would say, is to try to stay away from monster drinks and other high caffeine beverages, because that, caffeine is a diuretic. And so really just sticking with electrolyte replacements is better.
Thank you. Keeping with the theme of nutrition, diet, and intake of electrolytes and water. For with most people, there was a question on with most people having a fairly salty diet, how important is it to replace electrolytes in most workers, considering their daily consumption of salt intake?
I don't know if you, I guess I'll go first on that one. Yeah, I wouldn't, what you consume in your diet, your sodium content, it's not necessarily going to reflect your serum content. You don't want to eat, if you're thinking of eating a diet high in sodium, that's not really good. It's bad for your blood pressure. It causes increase in water retention, and it's not going to really help prevent you from having some of these effects that we mentioned. It's really the effects on the kidney and how well it's able to filtrate these sodium and potassium in particular. And so diet really won't influence that. It's really oral fluids that are going to more rapidly replace electrolytes.
I would agree there too. I mean, it used to be some time ago that salt tablets were given, but you have to be concerned about sodium and potassium, and those are very hard on the stomach, and also just a high sodium diet can be hard on the stomach too. So.
Thank you. There was a question on from Ron. Have you seen any employers who have taken steps to identify workers who are less tolerant to heat stress due to previous heat exposure, medications, body weight, and other factors?
Yeah, the answer for me would be yes. All of the above. All of those are factors increasing rates of hypertension. We want to recognize that, but yeah, it does make you more at risk for heat stress. So also the aging worker population is a lot of our populations in manufacturing are aging, and that makes them a lot more susceptible to heat stress.
I've seen some employers. I mean, obviously, if you have an occ health, like maybe an occupational health nurse with the company, they can help with that, or you're working with a clinic with an occupational physician, that can be very helpful, to help identify some of those additional factors. So, I mean, I've dealt with a lot of smaller employers, so they don't usually have those resources, but the larger employers that have the occupational medicine side definitely have that benefit.
Thank you. What about some best practices to hydrate when you're working from home, or just, you're expected to go out and work in the heat? So before you go out, what are those best practices?
I mean, from the standpoint of like staying hydrated, sometimes just setting a timer, setting a timer if you're out working in the yard, having a little timer to say, okay, we're gonna work for 20 minutes and then take a little break, can be very, very easy to implement. I think that's one of the easier ones.
Yeah, and I think just making sure that you want to stop, a lot of us want to push through a certain job and get it done. Really, yeah, just making yourself stop and rest, or dividing up your work so that you're doing something inside or where you're not exerting yourself. Really, really important. The other thing is that, yeah, with air conditioning, sometimes we can deacclimatize ourselves just because we're staying indoors all the time. And so if you have a job that you're planning outdoors, if you doing something on the roof, or where you're going to get a lot of radiant heat, really taking that into account, that you may not have done a particular job in 10 years and you're not the same person you were 10 years ago. So taking into account some of these different factors that we've discussed today is really important.
Thank you. Okay, there was a question regarding different skin types as far as like paleness versus darker skin, and I guess how if you're out of the heat, I think that would maybe the heat rash, if Belinda wants to comment on that and clarify it, how would that appear for those with darker skin?
Yeah, no, it's a good question. I think it's an issue, in dermatology period, is just to recognize different skin problems and with people of different colors, different tones. Yeah, prickly rash would appear, I think, on darker skin it would be the same. You would see these pustules, and then instead of probably red spots, it'd be a little bit darker. But they're slightly raised. That's kind of a clue. And then the symptoms would be the same with the prickly or painful sensation. Same areas, obviously, of the body would be affected. So I think from a standpoint of somebody trying to recognize these, I think that regardless of the skin color, they would probably stand out pretty well. I think it would be pretty easy to recognize on this one.
Thank you.
Well, I'll at least add, I mean, from the standpoint of being out there with workers working, under hot, extreme conditions, heavy physical activity, I mean, you can tell differences if, the face usually is the one that is affected the most from, the standpoint, and you can see differences in anybody's skin compared to maybe their neck, and so you can pretty much notice those differences.
Thank you. Okay, going back to shade. So for shaded areas, when outdoors working in heat, should you also have a fan for breeze?
Yeah, I mean, I guess it just depends on how hot it is, So if it's 105 degrees and it's humid, having a fan, may not be as effective. Maybe actually adding hot air onto the body. The shade's obviously going to help if they're outdoors, but it really depends. If it's, if the fan is going to help with evaporative cooling and the body can evaporate sweat, then it's going to be a good thing.
Yeah, I would say the physics are keeping in mind all the different ways that we lose heat, like cooling the temperature, convection, conduction, and so having air, moving air, will always be a benefit. But yeah, like Dr. Phalen said, with the higher the humidity is, the less able you have this evaporative effect. So the less effective that will be. But doesn't necessarily mean that you still you can, if you have a fan, I think it still helps people feel better. It can help them recover.
Thank you. And then keeping with the theme of kind of devices, we're asked to address whether wearable heat stress devices are proven technologies and are there limitations on their use?
Go ahead.
Yeah, that's interesting. I'm actually in the process. We're going to be doing some field research with cooling vests next month on a project that I'm on, and the main outcome that a lot of these personal cooling devices are a sensation of thermal comfort. It's more sort of on a survey. When asked. So there are a lot of emerging technologies, but there is evidence that they help that. And actually this thermal sensation has been linked pretty closely with being a fairly accurate representation of what one's core body temperature is. kind of the issue is with the testing of this, is that we can test these devices in a lab setting pretty easily, where we really are controlling the temperatures, and measuring core body temperature is not an easy thing to do. But where I think the research is missing is more field trials, like the one we're going to do, and so that's less like concrete evidence that these things work. Whenever you have extra cooling devices on, that gives you extra weight that you have to have, and so that's a kind of converse factor that's going to add more to the heat stress. So one has to keep that kind of in mind. But so I would say the research for the most part is not completely proven on that, but there's a lot of kind of lab studies that are showing some promise for it from my perspective.
I would agree as well. As far as the cooling vest, I mean, the studies out there there's ones that have shown positive results, ones that haven't been so conclusive, but I think for the future, I think there's a lot of potential there.
Thank you. And that kind of addresses the next question for oil and gas workers that have to wear all the gear, that are exposed to radiant heat. Michael asked, what have you seen to be successful for people who are over 150 pounds that wear all this gear, that are exposed to radiant heat, regarding cooling vests and other programs that have mixed reviews? I know when we went on some of our field trips, I mean, there are heat stress programs, and y'all have talked about some of these programs. So can we go into a little more details about, how these programs work? Dr. Perkison, you want to go first?
Yeah. So again, that's a real issue, is that we need to have the equipment that really fits all different sizes of people, and so that can be an issue. So if something's if a vest is too tight on someone, then that's not going to help them. They're not able to breathe as easily. It's provides sort of a more insulation effect. So yeah, making sure that you really try to have sizes that fit everyone. It works the other way too, is you can have vests that are too large for people. We have a lot of, I mentioned women in the workforce, or people from different parts of the world that are smaller stature. If that's not fitting them adequately, it puts them more at danger, because a lot of times if they're wearing these cooling vests, they've got to wear a safety harness over it. So really important to not just order things, but just make sure it actually fits. And then yeah, the kind of the basic fundamentals for me is establishing a medical surveillance program up front, where you're kind of addressing some of these issues. If you don't have a health department in your own company, partnering with occupational health, neighboring occupational health clinic, like a Concentra clinic, for instance, can really make a big difference, where you have some confidentiality, and employees feel like they're able to express some of these things issues that they have. And then having a good acclimatization program and an accommodation program, so that somebody has a medical illness or they've been out for a while, that you're having them introduced back to work. A lot of it's a real good culture, making sure that your managers understand that these issues are there, and that it's not somebody that's just trying to get off work or not do their job, that this is an issue, and also that we're encountering higher temperatures for longer periods of time. So having all these mechanisms in place year round, really, or being able to do that if the temperature changes. I guess that's kind of the fundamentals. I'm sure Dr. Phalen has a lot of experience too.
Yeah, no, I mean, I agree with all those points, and definitely with oil and gas on some of the plants and the sites. Some of the issues is there's not as much air moving around there. So because of all the structures, And then you tend to have quite a bit of radiant heat coming off of, especially if they're doing any kind of processing, radiant heat coming off of those surfaces. It becomes very difficult once you're adding on these layers of clothing, and in some cases, radiant type barriers can help. If it's radiant heat that's coming off of this, either just making sure that there's a radiant barrier between those sources, like line of sight, and the workers, or even just shading from the sun, can be very useful. You run into problems with requirements for things being intrinsically safe, so it becomes problematic with having fans and the like. But if they have compressed gas, like compressed air out there, which many do, because of those intrinsic conditions, you can run some fans off of that compressed air, and so there are some things you can do, but it becomes a real challenge. If they're having to wear respiratory protection, that's where going towards something like a PAPR, a PAPR, can help, at least have some airflow over the face, but it becomes challenging, and you have to try your best to try to address any of those issues that you can. The last thing is that's where, under those extreme conditions, some type of physiological monitoring and oversight, just making sure everyone's well trained, making sure that they understand the importance of hydration, they understand the importance of those breaks, and then understand the signs and symptoms for themselves and their coworkers, so they can protect each other. And then maybe turning to something like, checking temperature, body temperature, or heart rate recovery if they're doing heavy physical activity.
Michelle, I might add just a few things I was just thinking to add regarding heat stress programs. Another thing regarding these different devices, even though they're sometimes experimental or there's some evidence, having them available, I think, is just good for workers. It's something that if again the perception of thermal cooling is good, then that's kind of a good test. And it really shows the worker that you care about them, that you're thinking about them, that you're providing them with these services. And so free drinks, misting tents, personal cooling devices are all, I think, important, showing that you're part of it. That you're invested in their safety. Another aspect of it that we haven't mentioned too much is the importance of a buddy system, because as a health and safety professional, you can't be everywhere all at once in these plants if it's oil and gas, and sometimes people might be doing some work, off in a corner someplace where they're not being really supervised. So it's important that a lot of good health programs have a buddy system where you have someone else that's sort of in charge of the other person, and you're recognizing some of these subtle symptoms that might be having. I mentioned just a little confusion, a little disorientation. Sometimes that's the first symptoms, and somebody that knows that individual will actually be able to recognize that better and sooner than the healthcare provider can. Having people that are dedicated to monitoring your employees for heat stress specifically. So somebody in health and safety, or it could be even a operations person that's been designated to be kind of that point person, going around checking on people periodically, offering drinks, things like that, help you have the eyes and ears that you really need when you're out there. And then the last point is that the other thing that's changing in our temperatures is that the nighttime temperatures are not dropping down as much as they were. So sometimes we try to compensate with work that's being done more in the evening, and just being aware that that while temperatures are less, they're not they're not dropping like they were. And so the nighttime somebody can really get lost out there and be unsupervised. So if you have a lot of manual exertional work done in the evening, still maintaining the diligence in the evening is important.
I think I wanted to add one last thing. What's fairly common is companies, especially oil and gas, is with the clothing. I mean, it's usually preferable to have a darker type of clothing for the protective clothing, because it's like you touch something and you have some oil on it. Darker clothing doesn't appear soiled as easily, but some companies have gone with lighter colored clothing to at least help, if they're having that protective clothing, which can help a little bit. So that's another consideration.
Thank you both. All very good points for consideration. Moving on to COVID-19, we have a question on if any studies have been done on how COVID has affected the body's ability to tolerate heat, especially with COVID long haulers who are still experiencing COVID symptoms. So if either one of you can address that.
I guess I'll go. It's a good question. Certainly, I haven't seen studies specifically with COVID-19 and the ability to cope with heat stress. However, indirectly, it's certainly a factor to consider. We've seen prolonged respiratory effects with COVID-19. We've seen people with cardiovascular effects and prolonged fatigue. All of those making someone more at risk for the effects of heat stress. So I think in your return to work policies, that having, if somebody's been out with COVID, that's where your medical surveillance comes in. It might suggest maybe a little more robust medical surveillance that's sort of specifically asking for some of these long-term symptoms of COVID and taking that into account how you're returning people back to work.
Good point. Thank you. Okay, we have a little more time. If anyone has any more questions or comments, you can feel free to enter those into the chat. I think I have addressed all the questions that came in. Yeah. I don't see any more. Also, feel free if anyone has any questions or comments, you can unmute yourself to just ask those directly to Dr. Perkison or Phalen.
This is Ike. Good morning, everybody.
Morning.
Morning. Go ahead.
Good morning. Yeah. Just want to appreciate everybody, Charlie, Bob, and Brett, for the insightful and resourceful information we received today. And just want to ask, how best can we implement these mitigation measures when the company doesn't have 100% buy-in?
Yeah, that's always the challenge, right? I mean, it really is situational, depending on how you can get that buy-in. It's a concerted effort. I think my experience just working with a lot of different industries as a practicing industrial hygienist, it's a relationship you have to build. And you have to make sure that they know you have their interest, their best interest in mind. And I mean, I think that is probably first and foremost. As an industrial hygienist, we have an obligation to protect worker health, safety, well-being, and that's first and foremost. But the workers typically are not paying us. And we, ethically, we still have an obligation to the employer the client in those cases. So, I mean, building that relationship is important. So if your efforts are always in their best interest, and you're working to provide the best service you can, and a lot of times you have to understand the motivations of management and speak their language, and so I mean, from my own experience, the successes that I've had, or whatever I'm doing, my objective has been to take corrective actions, not to go and go into an environment and with a checklist and tell them everything that's wrong, but to actually do some corrective actions when I'm there, and to take action on my end, show them that I'm working to help make changes to improve, and then also bring things that in a light that, hey, this will increase productivity, or evaluating the fact that, let's say we've had 10 cases of heat stress, and there are costs associated with that, and so management may be more centered on costs and productivity. So sometimes we have to speak their speak, and keep that in mind, So it's a balancing act, but my experience is if you're really making those efforts to protect the organization along with the workers, and you're doing what you can to improve conditions and improve productivity and reduce injury and illnesses without the stuff that will require funds, it's more likely that they'll give you the funds, when you need them. I don't know if that helps.
Yes, it does help. Thank you very much for that insight. So it's good to have good relationship and talk the money terms in terms of the cost in reduction and illnesses and other programs. Thank you very much, Bob.
Yeah, you're welcome.
I might, I guess, just that, one of my experiences wasn't so much with heat stress, but it was with wellness programs. But I think it's a very similar kind of approach, and so I felt like I got a lot of traction when I really look at us in health and safety as being we're sort of like the science officers for this organization that you work for, and so talks that occur early in the spring when you're going around and you're doing preventive talks should include information about heat stress, but it also should include some statistics about the number of heat-related fatalities, ideally in an industry similar to yours, and provide them with these facts about what happens, and making them aware of it, because these fatalities are going up every year, and so they need to be aware of that. And then I always feel like it's important to stress the health issues first, and so you talk about how you're preventing people from getting ill and illness, but then like Bob mentioned, the productivity, and if you can even try to be as specific as you can. Again, you can consult the literature, but which is not too developed, but just looking at productivity, there is some literature out there that talks about you can have more productive workers, you can have less injuries and illnesses when people are staying healthy, and you have less heat-related illnesses that result in higher productivity. One example we were looking at in pipe fitters as to way of measuring the benefits of a cooling vest was looking at the effects, the number of welds that they do that are rejected. So pipe fitter will do a weld on a pipe, and then they do an x-ray to look at the quality of the weld, and then it's good. If it's not, they have to redo it. Looking at something like that, what are the number of rejections on people that are having these heat stress interventions there at the site? So something very concrete and tangible, sometimes can make a difference in really kind of selling the case. And then the other thing is, just like wellness, everybody always wanted a gym at the manufacturing site, a full-blown gym, and They go, we're not going to build a gym. It was always this back and forth. But really thinking about when you're doing a heat stress program, do something that's low investment and high yield. So simply having drinks out at the site and maybe establishment of a buddy system. Not that much cost, but you can make a big difference if you're measuring things. And that could be just simple, like a simple heat survey about how people felt. Really kind of showing them this data and being objective about it can make a big difference. And so not going with the big guns with this big, huge misting tin and a cafeteria out there, at the first thing, show that it works with a low investment, high yield program.
Thank you. Okay, we have about 10 more minutes, and some questions and comments came in from the chat. So we'll address a few more questions. I don't know that we can speak on OSHA as far as on their behalf, but there's a question on how can OSHA develop a heat stress standard that isn't one size fits all? How would you proceed? I mean, obviously some of that was talked about today and on-site programming, but if you all can comment on maybe some recommendations on how to get around that.
Yeah, I mean, well, yeah, California came up with a heat stress standard. Maybe it was sometime just before like 2015 or something like that. They've had some, and it's fairly straightforward. It's water, rest, and shade. So, it definitely had some challenges when they implemented it for primarily the agricultural industry, because providing shade can be a problem if you have 100 people out in a field, and I know many of those companies just definitely had difficulty. They were having to buy, some of them 50, 60 of these shades and be putting them up and moving them because people are moving around the fields. But yeah, it's a fairly simple approach. And I know from a federal standpoint, OSHA is looking at and probably will be coming up with a federal standard for heat stress. It's similar to that of California. So I don't think the California standard isn't very long. It's just kind of water, rest, and shade. And so I think those are important considerations if people are doing physical labor under odd conditions. So I think there's plenty of ways that organizations can implement that, however I don't think it's too prescriptive.
Yeah, I would just add, that's exactly the example I was going to give was the Cal OSHA heat stress program. And, they specify things like having a distance for the fluid to be near workers, so it's convenient. So you can imagine the agricultural workers, way out in the fields, and then they have a place, a rest station 2 miles away. There's a lot of like sort of loopholes, that are not that great. So you have to be kind of specific. So, but I think that's a good pattern. One of the big issues on a national level that's kind of there's been heat stress bills that have been proposed now for quite some time, and they're still sort of in Congress getting worked out, both in the Senate and the House. But it's involving, if you follow the strict guidelines on heat stress programs, that for a given heat index, you have to have a certain amount of rest breaks, and y'all are probably familiar with those. So that if it's getting up to like 110 degrees, then you're only able to work like 15 minutes until you take another break, and so it becomes like very difficult to make people actually, people are actually able to work because they're hard to go in those environments, and those things, and so that's what's getting it tied up a little bit. But I think yeah, adopting something like the Cal OSHA and focusing on that, is a good start. I think, on the federal level, OSHA needs to take into compensation not following those work rest breaks, but providing, engineering it so that they're just not in that environment, or they're working at night or something where they're not in these areas where it's so hot that they can't do hardly any work at all.
Thank you. We have a question about OSHA reporting when heat stress fatalities. How underreported do you believe heat stress fatalities are when the cause of death may be from various causes where heat may have been a factor?
I mean, I guess it's a fair amount of conjecture. So I haven't seen any studies that try to kind of go back and look at it. But my experience is, and my sort of thought is, the fatalities are probably pretty accurate. Like when somebody develops heat stroke, it's a pretty good diagnostic. The symptoms that shows up, and so that's fairly accurate. I think what's not accurate are the cases of medically treated heat exhaustion, where somebody's getting IV fluids, and so you have a diagnosis of dizziness or vertigo or something that doesn't really take into account heat. That's what I think is really underreported, and I think that goes true with kind of OSHA recordables in general. These and I think the more, which is one of the reasons why in the presentation I was kind of deliberate in those slide presentations of keeping in mind the OSHA recordables. If you get an IV, if you get IV fluids, it's an OSHA recordable. If you go to the emergency room and your prescription substance, it's an OSHA recordable. Is that we really have to kind of get away from worrying about an OSHA recordable in order to prevent people from dying or having these permanent disabilities. Is that and selling this in advance to management that, look, this is a subtle thing, we gotta move on it, and having them understand these symptoms so that you don't get burned for it afterwards, for recommending that. But I think getting everybody on board, because that's all has to do with OSHA recordables, and sometimes that can really impair how we treat people.
Thank you. And there's a question with some acronyms, so I'm going to try my best on should not heat HRI be included on the JSA?
So it's heat-related illnesses be included on the job safety analysis.
Thank you.
Yeah, I think that's a good idea. I mean, especially if they're doing work around furnaces or hot surfaces or outdoor work. Yeah, I don't think it's something that probably is typically thought of. So I think that's a good point to include heat, in your JSAs or JHAs, job hazard analysis. From the industrial hygiene standpoint, we'll do one or the other. But for those that may not be familiar, a JSA is you're just breaking down the job, the task, you're identifying the hazards, and then you're recommending controls along that process. So if there's a task that involves many components to it, then making sure that they have the proper protective clothing, equipment, or the proper protective devices in place, and heat would fit right in there.
Thank you. Okay, so we only have a few more minutes and we have some comments, but one question that I think was already addressed, but maybe just one last comment on wearable heat stress monitors and their limitations. We talked about, some benefits, or if you have any information about maybe some resources for people, that would be good to put in the chat as well.
I'll put in the chat, the one I have experience with is that they were doing for this project I'd mentioned was a Zephyr Bio Harness. It's a little device about 2 inches in diameter that fits on a strap around one's chest, torso. Yeah, you know, a lot of these are being used in sports and in professional athletes and also the military. But I haven't seen it as much in the literature on workers in manufacturing. So I you know, so far I like what I see. I think some of these things are really, you know, interesting and accurate and can help. And my own kind of thought on it is that you probably don't want every single worker walking around one of these chest straps. But if you did have a sample of folks out there and that you're able to monitor, it could be of some use. So certainly the technology is developed enough that you could think about, investing in that is a way of kind of monitoring your employees. But we don't have a lot of good templates for you at this stage, from my knowledge.
All right, thanks for that. So, folks, we're out of time. It is 10:30 Central Time on the dot. So I just want to thank you all for attending, and thank you sincerely to both Dr. Perkison and Dr. Phalen for your wonderful presentations, information, and your time today. This has been a great webinar, very informative. I think we got through all of the questions. So if anyone has any follow-up questions, you can feel free to email us at the email address on the registration page. Be sure to connect with us on our website. And we will be sending out evaluations and certificates to the email you registered at. So please check your junk and spam folders. But if you have any issues, feel free to email me. So thank you, everyone, and have a wonderful day.
Yeah, thank you, everyone.
Bye-bye.
Thank you. Thank you, everyone.
Thank you.
Thank you too.